So in this next video, we're going to do some follow-up pairwise t-tests to see if all of them are significantly different from each other or if just some of them are. Now, in order to actually do this with all of the pairs, we'd end up running a lot of tests. So I really just want you all to get the idea of how we would go about doing this. And I've hand selected just testing the groups that have relatively close average sale prices. So we're going to do pairwise t-tests for Brookside and North Ames. Then we're going to do a pairwise t-test for Crawford and North Ames, and then we're going to do pairwise t-tests for Crawford and Somerset. And I feel like after those, we'll be able to tell if all of those are significantly different from each other, then we could probably conclude that each of the boroughs have a significantly different sale price. The only one that we're not going to include if we were to do the full pairwise test would be Brookdale, because it only has 20 observations in it, and we'd like for them to have at least 30 in order to be well represented enough to hold up to these tests. So the cool thing about our pairwise t-tests is we don't have to have equal variance. In fact, we're going to choose the test that assumes that the variances are not equal. We do lose a little bit of statistical power to test differences, but it's still a reliable method in order to kind of assess the relationships between these things. So those pairwise t-tests are also in our data analysis tool pack. If we scroll down to the bottom, you want to make sure that you're selecting the one assuming unequal variances, because we can see over here that we have very different variances among these groups. So I'm going to select assuming unequal variances, and then I'll clear out these so that we can fill them in together and make sure that you guys have all the criteria correct. Okay, so the first one we're going to do is Brookside and North Ames. Brookside is about $120,000 on average. North Ames is about $156,000 on average. So those look to be pretty different, but we're going to perform this test to see if statistically they are that different from each other. So in variable range 1, I'm going to select my Brookside variable from the label all the way down to the last observation. So I've clicked on the label inside the range box, and I'm going to do Control Shift and down to select that column, or Command Shift and down if you're on Mac. Okay, variable range 2. We're going to select that North Ames borough. So again, I'll click on the label in H1, Control Shift and down to select that full column of data. Okay, the next thing that we need to do is to put our hypothesized mean difference. So our null says that these two things are equal, so if we were to subtract the means from each other and they were the same thing, we would get a difference of 0 because they would be equal. So for all of these tests, your hypothesized mean difference will always be 0. We're going to check this box for labels because we do have our labels in the first row, and then our output range will be a cell over here to the right of the data towards the top of the sheet, and we'll press OK. And we'll get our little bit of output here, okay, and we'll clean it up a little bit so that we can make sense of all of it. Okay. I'm going to do a little bit of formatting on this one, and then we'll copy and use that format painter for the other two tests that we'll run. So these means, these are dollar values. We can round them to no decimal places since they're so large. These variance measures are here. Again, we don't have to worry about them being equal anymore. There's our hypothesized mean difference. Our t-stat, we can take down to a couple decimal places. And then our p-values here will also reduce. Oh, let's change them to a number first, and then we'll have at least 3 decimal places. So the p-value that we're going to focus on here is this two-tailed critical p-value. Okay, we can see it's very small. That would be an indication that these are significantly different, that the average sale price for the Brookside borough is significantly different from the average sale price for the North Ames borough. Okay, and again, this is, we don't have to overly format these tables, just make them nice and neat and easy to read for your purposes and to paste into your homework submission form when you do it on your homework data. Okay, so we're going to do another test. This time we're going to do our North Ames neighborhood and our Crawford neighborhood. Okay, so go back to data analysis, to sample t-test. I'm going to take that North Ames and paste it up here in my variable 1 space. And then we're going to select that new neighborhood Crawford. So I'll click on G1 where it's the label for Crawford, Control Shift and down to select that data. And the only other thing I'm going to want to change is this output range. I'll just paste it right below this first table and press OK. Now the cool thing about that format painter, I can highlight this table here. I can go to my home ribbon, click on my little paintbrush here, and I can paint that formatting over here so that everything's looks consistent throughout. Okay, and then the last test that I'm going to do, because they look to be a little bit close, is the average for Crawford and the average for Somerset. So going to my data analysis toolpack, okay, unequal variances. I'm going to take my Crawford variable and put it in variable range 1 so that I can put Somerset here. Click in J1, Control Shift it down to select that data. And then the only other thing we'll change is the output range. Now, if this feels like it's going a little fast, I have posted pictures in the lab lecture slides of these input sheets. So if you're like, oh man, like, you know, by this point in the semester, hopefully selecting data is easy for you. You can always pause the video or slow it down if you need to make sure that you're able to get everything. But there are pictures of these little input screens with all the correct information in them. Okay, so paste that last one, and then we'll use our format painter. Oops. To paint over this table and have it nice and neatly formatted. So again, I chose these combinations because they are the combinations where the sale prices are like relatively close. But one thing that we see is that in each of these tests, our p-values are all very small. So what this is telling us is that Brookside is significantly different from North Ames, that those are far enough apart, those average sale prices are far enough apart for this to produce a significantly different result. And so if this one and this one are significantly different, then we can be sure that it is also significantly different than any borough that has a higher average sale price than North Ames. So Brookside would be significantly different from this one, from this one, from this one, and from this one, because each of those other neighborhoods are farther apart in its average than it is than they are. Okay. Same thing here. You know, these two were significantly different. Oops. So if North Ames is significantly different from Crawford, then it's also got to be significantly different from all of those boroughs that have a higher average sale price than Crawford. Okay, same thing. Crawford and Somerset, those were the other two that were relatively close. These are also significantly different. So just by kind of creatively picking a few pairs, we're kind of able to extrapolate that if we ran all of these tests, then they would all come back to be significantly different, meaning that all of the average sale prices for each of these neighborhoods are significantly different from one another, and there's really no justification for combining neighborhoods together. The only one we would have to worry about here would be this underrepresented category. So in each of these cases, we would reject the null that says that these two average sale prices, these two means are equal, and we'd conclude that they're not equal, that they are significantly different from each other in each of these three cases.